Hi guys, welcome back to my YouTube channel. So in today's video we are doing integration by parts. Please do forgive me for the previous video. I kept on saying integration by parts instead of integration by substitution, right? So we are doing integration by parts and we have two cases, but before we get to that, please kindly note that I will be hosting a bootcamp and it's just going to focus on tests, no content discussed. Hence, I'm doing these YouTube videos so that you guys understand the basics, right? In that bootcamp, we are only going to be doing past papers. I am trying to secure a venue because I've heard your guys' cries on how you don't like online and whatnot. So I'm trying to secure a venue for it, and I'll let you guys know how that goes, right? Without wasting more time, let's get right into today's content. So integration by parts, right? So with integration by parts, we are basically saying you're going to use a specific function, right? And I have this function written right here. So this function is this, right? Where you have uv minus integral v times u I dx. So if you check in this function, you have three things. Actually, you have u. Oh my god. Okay, wait. Sorry, guys. I'm still trying to get used to this, so forgive me. Okay, so you have u, right? You have v, and you have u1, you have v1, right? So you have four things. So what we are trying to say is that you're going to be given, right, and that brings us to the cases. You're going to be given two functions, right, the first one and the second one. So you're going to be given two functions multiplying each other, and between those two functions there's going to be a function that you know how to integrate and a function that you know how to differentiate, right? A function you know how to integrate and a function you know how to differentiate, right? So the function that you know, so you look at your function and you ask yourself, which one can I integrate? Which one do I know how to integrate given the rules that I do know? And yeah, given the rules that you do know. And which one do you know how to differentiate given the rules of integration that you have learned, right, when you started calculus? So if you look at the first case, I have some function f of x, right, and it is multiplying the function e to the power of kx. So this is a function that I can integrate. So I can integrate this function. So with integration by parts, you need to find what you can integrate, and you will call that v1, right? And you need to move that to v. So whatever function that you have identified that you can integrate, you take that function and you make that function v1, and then you integrate that function because you can integrate it. And whatever that is left now becomes your u, right? So there are two things that you need to find. You need to find a v1, right, from the given function that you're trying to integrate, and you need to find a u, right? So that's the first case. So if you look at our first case, what can we integrate? We can integrate e to the power of kx, right? We learned from our basic rules of integration that that is going to be writing the same function as it is and dividing by the k, right? So because we can integrate that function, it becomes our v1, and we now need to move that v1, right? v1 is like when you're differentiating v, right? So it's the differentiated version. It's the differential function. So you need to move the v1 back to the original 1v, right? And how do you move from v1 all the way to v? You have to integrate the v1 function, right? That's why you have to look for a function that you can integrate, because you want to move that function to its original function, right? And then whatever function that was left, in our case it was f of x, we make that u, right? And then we now differentiate this function. So it's going to be differentiate, integrate, right? So we know how to integrate e to the power of kx, as I said. So you make that v1 and then you integrate it back to v, back to its original function. That's what integration means, undoing the differentiation. So meaning moving from v1, moving from f1, moving from g1 back to g of x, back to the original function, right? And then we have the second case, right, where you have a ln function now. You have some function, right, multiplying a ln function. So you have two cases under integration by parts, where some function is multiplying a function of e to the power of kx, and some function multiplying a ln function, right? So if you guys remember from differentiation, we can differentiate a ln function. So that becomes your u, and then the other function now becomes your v1. It's as easy as that. And as I said, the basic rule is that you find your u1 in the function, you find your you find your u in the function, and you find your v1 in the function. Then you move the u to u1. So you write the u down, and then you find it's u1, right? Meaning differentiated. And then you find the one that you can integrate, you make it v1, right? And then you integrate it and you find the v. Now you're going to have 4 variables, right? And you'll see how we use those. So let us look at 4 examples that I have. So with integration by parts, this is the rule or the formula that you're going to be using, all right? So the first question says, let's use black to answer the questions. So the first question says, integrate the function x plus 2 times e to the power of 2x. Obviously that times is not there. I'm just putting it to make it clear. All right, so that was the first function that we had, this one. All right, let's integrate that function now. I said integration by parts is used when you have some sort of function multiplying an e to the power of kx function, or it is used when you have some sort of function multiplying a ln function, right? And then now you need to ask yourself, what can I integrate? I have the first function and I have the second function. Which one can I integrate? Which one can I differentiate, right? So the most complicated one here is e to the power of 2x. Yes, because someone can say, see, I can integrate x plus 2, so why not take that one? You need to ask yourself, see, which one seems most complicated, and then you ask yourself with that one first whether you can integrate it or differentiate it, so that you know what to do, right? So which one seems more complicated? The e to the power of 2x seems intimidating. So I'm here and I'm like, can I integrate e to the power of 2x or can I differentiate it? I can integrate it. So if I can integrate it, I make it v1 is equal to e to the power of 2x. And I said when you're at v1, you need to move to v, right? And you move from v1 to v by integrating. And we learned previously that using the basic rules of integration, this is going to be e to the power of 2x over 2. All you do is you take the k, which is the coefficient of the x, and you divide the function, right? And then whatever that is left becomes my u. So my u is going to be x plus 2. Once I have the u, I need to find the u1. It's just going to be 1. Right? And then you use the function. After you have found all your 4 variables, your v1, your v, your u, your u1, you now need to go to this rule that I talked about, right? And substitute into that rule and then work out your answer. So the function, the rule says uv minus integral sign v u1 dx, right? You haven't integrated as of yet. As I said, with integration, it brings you to a function. It rewrites your function in such a way that you can now integrate it, right? So these were the rules that you had to follow to rewrite that function. So my u, I just copy from here, from what I just wrote. My u is x plus 2. My v is e to the power of 2x over 2. Integral sign, right, times v. My v is e to the power of 2x over 2. My u1 is 1 dx, right? And then you rewrite this as it is because there's nothing to do with it. There's no integral sign in front of it, so you just rewrite it as it is. All right. And then on the other side, there's an integral sign, so I need to integrate that part, right? So I have a 1 over 2, right? So I can take that to the other side of the integral sign. Integration says we can do that. And then I just have e to the power of 2x, right, times 1. That is just the basic e function, right? So you're going to rewrite this as it is. And then you have negative 1 over 2, right? E to the power of 2x. The rule says divide by k. My k is 2, the coefficient of x. So my answer should be x plus 2 times e to the power of 2x over 2, right, minus 1 over 4 e to the power of 2x, right? And then not forgetting my c. So that should be your answer, right, for the first one. And then for the next sum that we are looking at, the sum says integrate 2x minus 1 times ln 3x. So remember, with integration by parts, we said we only have two cases where you have an e function and where you have a ln function, right? You look for what you can integrate and what you can differentiate. Where's your starting point? You ask yourself, which one looks more complicated in the function I'm trying to integrate? So in the one that I'm looking at, the ln looks complicated. And then I ask myself, can I integrate that function or can I differentiate that function? I can differentiate the ln function. I can't integrate it. We didn't learn how to integrate it, right? I can only differentiate it. So if I can differentiate it, I make it u ln 3x. And then I find my u1. To differentiate this, the rule says find g1 of x over g of x. The rules are going to be given in your formula sheet. So if you forgot how to do it, just go to your formula sheet, right? And the g of x is the function that is inside of the ln, right? When I say ln, I mean this. That's ln. Okay, and then g1 of x. So I need to find g1 of the 3x. And it is just going to be 3 over the function itself, so 3x. The 3's cancel out. This is just going to give me 1 over x, right? And whatever that was left now becomes my v1, and it's going to be 2x minus 1. I integrate that, right? It's going to be 2x to the power of 2 over 2 minus x. So it's going to be x squared minus x. If you don't understand how to do this, go back to the basic rules of integration. Go back to the basic rules of integrations video. If you haven't subscribed, make sure you click that subscribe button, right? Now we have all our 4 variables. What's the next step? To use the rule, right? The rule says uv minus the integral sign v times u1 dx. Let's just confirm. Yes, that is the rule. And now you substitute, right? So you have u, which is ln 3x. And then you have your v, which is x squared minus x. And then you have minus the integral sign v. My v is x squared minus x. My u1 is 1 over x. This is times dx. All right, so you rewrite this function as it is, minus, there's an integral sign, so I need to integrate, right? But before I integrate, I'm just going to simplify further, because it seems like I have a common factor here that if I factor out, can just subtract what's here, right? So I just factor out the x. I have x minus 1, right, times 1 over x dx, and then the x cancels the x. I still have the same thing minus the integral sign, and now I'm left with x minus 1 times 1. So I just have x minus 1, right, dx. This is still going to follow as it is. If I integrate the x, it's going to be x squared over 2 minus x. Sorry, when I integrate, I need to let go of the integral sign, right? And this is in 1 bracket. So if I were to rewrite my answer, it is now going to be ln 3x, the one we have just been denoting as this, times x squared minus x, right, minus this, which is minus x squared over 2 plus x plus my c. right? And that is your answer. Okay, let's move on to the next one. The next one says, which is number 3. So, sorry. Number 3 says integrate 2x squared e to the power of negative x, right? Go to the most hard one and I ask myself, can I integrate or differentiate it? I can integrate this, so it becomes v1. Excuse me. And then I integrate it. It's going to be negative e to the power of negative x. And then my u becomes the other function. Find my u1. Right? And then use the rule. The rule says uv minus the integral sign v u1 dx. Right, and then you substitute, guys. It's as easy as that. So if you're finding this hard, it must be easy to you by now. You just need to be careful that you do not substitute the wrong thing. The v is negative e to the power of negative x. The u1 is 4x. All right, dx. Okay, this is going to remain as it is. I just need to work with the integral sign, right? So I can take the 4 to the outside, and I'm just left with integrating negative e to the power of negative x, right, times x dx. So if you look at this, right, to be able to integrate this part, I need to use by parts again. So this is where integration by parts gets complicated. Sometimes you need to use it twice, right, to get to your final answer. So in this instance, I need to use it again. All right, so I'm just going to move my workings here. To be able to use it again, I need to follow the same steps. I find what's more complicated. This is what's more complicated. Then I ask myself, can I integrate or differentiate? I can integrate, so it becomes v1. Right, and it's gonna be, I'm working with the new function. Don't get confused. I'm done with using these ones. I'm now here, right? My v1 is gonna be negative. Let's make it, I want to make it positive. It doesn't matter really. Let's make it negative e to the power of negative x, and then I find my v. My v is just gonna be e to the power of negative x, right? Because I'm gonna take the negative e to the power of negative x divided by the k, and the k in this instance is negative 1. Negative 1 divided by negative 1 is positive, so I have positive e to the power of negative x, right? And my u is gonna be the other function that was left, which is x in this instance. My u1 is just gonna be a 1, right? I still have that function, right? So I still have the 2x, so I still have 2x squared, right, negative e minus x, right, minus. I'll open a big bracket, right, because to integrate this, I use by parts, and by parts means that I need to go back to this function. The function says uv. My new u is x. My new v is e to the power of negative x. I'm working with these ones now. All right. Minus the integral sign v, which is going to be e to the power of negative x. u1 is just 1. Then dx. Okay. Okay, and then if I had to simplify this, I will have negative e to the power of negative x, right? So I will have negative x e to the power of negative x plus integral of e to the power of negative x dx. To be able to integrate this, I just use the basic rule of integration. So I'll just have the same thing here, plus e to the power of negative x over negative 1, right? So to get to the final answer, it's going to be 2x squared negative e to the power of negative x. negative x e to the power of negative x, right, minus e to the power of negative x plus c. All right, let's see if I got that right. This was number 3. Okay, there was a negative 4 somewhere. Oh, I forgot this 4. Okay, there was supposed to be a negative 4 here, right? So it's supposed to be plus, so it's supposed to be negative 4 here, so negative 4, right? I forgot the 4, guys. Okay, the 4 was on the outside, so it needs to affect everything. So I'm also gonna have a 4 here. Sorry, I had forgotten this 4, so don't make the same mistake as I did. Don't forget anything. That's the thing with integration by parts. When you integrate the second time, you end up forgetting important things. But yeah, that ends up being your answer. I do these sums before, like I teach them to you guys, so that I don't get stuck, because sometimes you get stuck. That's just how it is. Just because I'm tutoring doesn't mean I don't get stuck while doing those questions. So I have to do them first, right? So that's how I'm able to see and just cross-check if I still have the same workings. Right, and this is the last one. Don't forget that we'll be hosting a boot camp, right? It's 280 rands, and I'm trying to secure a venue because you guys don't like online sessions. But here you are watching the YouTube videos. But anyways, you ask yourself, which function is more complicated? Is the ln x in our function? Can I integrate or differentiate that function? I can differentiate it, so it becomes my u. I find my u1, which is just going to be 1 over x. Whatever that is left becomes my v1. I integrate that, and it becomes x to the power of 3 over 3. I use my function. I keep forgetting this function. Minus integral of v u1 dx. Okay. You substitute. This should be easy to use. Should be second nature by now. We've been doing it. Ln x. My v is x to the power of 3 over 3 minus the integral of v, which is x to the power of 3 over 3, times u1, which is 1 over x, right, dx. Okay, if you look at this and this, they can cancel out, right? When I cancel out x cubed with x, it's left as x squared. So I still have the same thing here. I have minus, I can take the 1 over 3 to the other side, right? And I'm just left with x squared dx. This remains as it is, 1 over 3, x to the power of 3 over 3. All right, and then the 3 multiplies the 3. I have a negative x to the power of 3 over 9. If I were to also rewrite this, it's going to be ln x to the power of 3 over 3, right, and minus x to the power of 3 over 9. Let's see if that is what we had. Yeah, just don't forget your c because it's indefinite integral. And that should be your answer. And this brings us to the end of today's video. If you haven't subscribed, please make sure you click that subscribe button. Don't forget to like, comment, and share, even if it's just a thank you. It really helps to know that you guys are enjoying the videos. If you have any questions, please post them under the comment section, and I'll try to get back to your questions. I'll try to get back to them. Bye, guys.